Hello everyone, I am Divya, working for the Department of Computer Science and Engineering. In our previous classes, we have seen different threats that a network is going to face, and also we have seen that there are various methods through which we can encounter these attacks. Under that, we have studied there are cryptographic techniques as well as authentication methods used in order to encounter the threats that a network is facing. So, under cryptographic techniques, we have seen that there are two methods. One is secret key encryption and another is public key encryption methods. So, today we will start with the first, that is secret key encryption. Okay. So, today's topic of discussion is secret key encryption methods. Okay. Secret key encryption protocols, they are also called as symmetric encryption. Okay, and we can also call this as single key encryption protocols. Okay. This can also be called as symmetric encryption protocol or single key encryption protocol. Why do we call it so? We will understand it now. Okay. And this method is the most conventional method that we have. This is the most conventional method that we are making use of in order to encrypt. Okay. Under secret key encryption or symmetric encryption, all that is that we have is three things. One is encryption algorithm, okay, and then we have decryption algorithm and a single shared secret key. Okay. These three things plays a major role in this case. How it's going to play? We will see. Now, we have a sender here and we have a receiver here. Okay. Sender want to send his information to receiver through this channel. There are many threads in between, okay, since it is passing through a network. So, what we will do? We will have a security check here where encryption algorithm is used. Okay. Whatever message that we want to pass from this end to this end, that message is encrypted with the help of key, the secret key that we have. Okay. It is encrypted. Okay. The output at this point is called as ciphertext. Okay. And then this is made to pass through the network. Even if any intruder gets an access to this ciphertext, it is almost impossible for him to decipher what exactly this means, because it is not in its original form. It is encrypted or shuffled in such a way that it is not so easy, almost impossible for an intruder to depict what exactly it means. Okay. Then the message traverses through the network. At the receiver end, here we have decryption algorithm. Okay. Again, we are going to make use of the same secret key which we had here. The same secret key which we had here is going to be used here. That is why we call this as single key encryption method. Okay. So, with the help of this key and the decryption algorithm that we have, whatever ciphertext that is passed through the network is decrypted back to its original form and the actual message is given to the receiver here. So, we have seen why we are calling this as single key, and one more term I have used, that is symmetric. Why is it called as symmetric encryption protocol? Because whatever procedure that we follow during the encryption phase of the message is followed in a reverse order here at the decryption phase. So, it is called as symmetric. Okay. So, this is about the secret key encryption. Here the confidentiality of the data is maintained by encrypting and then decrypting at the receiver end, right. So, the secrecy or the security assurance can be given only with respect to the shared key, because key is the only thing which need to be kept as secret. Otherwise, encryption and decryption algorithms are made as public. So, the security of the message from or the confidentiality of the message from one end to other end can be assured as far as the secret key is kept secured. Okay. So, that is about the secret key encryption algorithm. Under this, we are going to study two protocols. Okay. We have plenty of protocols available for encryption and decryption. Here under this we are going to study about two things. One is DES and another is AES. These are the two protocols that we are going to study about. What do we mean by DES? DES is nothing but data encryption standard. AES is nothing but advanced encryption standard. Both are encryption protocols. How it is going to work, we will see to it one by one. So, we will begin with the first one, that is data encryption standard. How exactly it works on the given text, we will see to it. Okay. Now, we will see how the data encryption standard protocol works. Here our DES encrypts 64-bit data as a block. So, whatever may be the length of message, that plain text message is going to be divided into 64-bit blocks. Okay. It is divided into 64-bit blocks. Okay. And then it is permuted or shuffled. And the key here we are using in order to encrypt is also of size 64-bit. Okay. Out of 64-bit, 56-bit is of use and the next 8 bits are used as a parity bit here. Okay. Only 56 bits of secret key are going to be used here for encryption and remaining 8 bits are used as parity bits. Okay. In the plain text is further after shuffling at the initial stage, it is further divided into 2 halves of 32-bit size. Okay. 2 halves of 32-bit size, and one is called as Li and another is called as Ri. This entire encryption protocol consists of 16 rounds. Okay. Round 1 to round 16, all 16 rounds are performing identically. Okay. So, the plain text of 64-bit block is subdivided into 2 halves of 32 bits each. One is called as Li and another is called as Ri. Since this is the first round, I am going to call this as L1 and R1. Okay. And then the secret key that we are using here is also of 64-bit size, and among those 64 bits, 56 bits are considered and they are also divided into 28 bits here. Okay. Divided into 2 halves of size 28 bits, and then they are rotated and shuffled, and then they are permuted, okay, and the resultant 56-bit key for this particular round, that is K1, is fed as an input to this function. Okay. Here, after dividing the plain text into 32-bit halves, it is fed into this operation like this for permutation. Here Li is calculated as, or Li is considered as R minus 1, and Ri is considered as, if you look at here at this portion, your Li is directly fed from Ri, right, Ri. So, your Ri is a combination of Li. We are using exclusive OR operation, logical exclusive OR operation here. So, your Ri here is a product of, or the output of exclusive OR operation on two operands. One is Li and another operation is the function. What is that function? For that function, we are passing two things. One is Ri minus 1 and Ki, right. So, whatever output that we get by performing this function is XORed with Li, and that is fed as Ri here. Okay. So, these are the two equations that we are using, or considerations that we are using in order to permute this particular plain text, and then it is permuted again and it is forwarded to the next round of action. This action, the splitting of key and then rotating it and then permuting it and forwarding this as a key to this round for this particular round, and then splitting of plain text and then XORing that, performing XOR operation for that using those two equations and inputting that for further permutation. After permuting this, after performing permutation operation here, it is then forwarded as an input to the next round of operations. So, same thing is going to be repeated for 16 times. Okay. At the end, at the 16th round, we will get the cipher text as an output, which is going to be transmitted over network. Okay. Here, I forgot to say one more thing, how this F works. We have 32 bits of block here, plain text here. So, Ri is of 32-bit block, okay, and our key is of length 56 bits. Among these 56 bits, 48 bits are considered from key. Okay. Among 56 bits, 48 bits are considered from key, and they are split into 8 blocks. Okay. Key is split into 8 blocks of 6 bits each. Okay. And then this 32 bits Ri is also subdivided into 8 blocks of 4 bit size. Okay. What will happen to our Ri? Ri will be divided into 8 blocks of 4 bits in size, and then it is enlarged to match the size of K, because our key is of 48 bits length. So, 32 bits Ri is enlarged to 48 bits. How it is going to be done? We have divided Ri to 8 blocks of 4 bit size, right, and then for each of those blocks, consider if we have Ri something like this, we have 8 bits of 4 bits, 8 blocks of 4 bits in size. So, leftmost bit of the right side block and rightmost bit of the left side block is added to this 4 bit block, and it is made as 6 bit. Okay. So, we have 8 6 bit blocks of Ri, 8 6 bit blocks of K, that is key. Those two are XORed using this operation. Those two are passed as an input to this operation. Okay. And then whatever output that we get from this function is fed once again as an input to this along with Li and once again we perform logical XOR operation in order to send as an input for this stage where it is this Li and Ri is again permuted in order or shuffled, and then the resultant Li and Ri is fed as an input to the next round. So, this entire procedure is repeated for 16 times. So, we have 16 rounds here. At the end of 16th round, we are going to get the cipher text, that is encrypted text. This is forwarded to the receiver. The same procedure which we have followed from here to here is followed in the reverse order in order to decrypt that message on the receiver end. So, this is how our data encryption standard works. Is that clear? So, and having an understanding of this, we will move on to the next protocol, that is advanced encryption standard. Okay. Advanced encryption standard also splits the given text into blocks, and then encryption is done here also. Advanced encryption standard provides the more powerful solution or powerful encryption method for us compared to our data encryption standard. Here also the same methodology is involved. Again the plain text is going to be divided into number of blocks, and then it is going to be encrypted using a key here also. Here the size of secret key that it is going to make use is 128 bits or 192 bits or 256 bits depending on the size. Okay. And depending on the size of secret key, the number of rounds are determined. Usually it will have around 10 rounds. In DES we had 16 rounds, here usually we will have 10 rounds of operation performed on the given text in order to get the cipher text as an output. Okay. We will see how it works. In case of advanced encryption standard, as I already told you, the secret key that we are going to make use is, it can be of 128 bits or 192 bits or 256 bits depending on the requirement. And the number of round also varies from 10 rounds to 14 rounds depending on the size of the secret key as well as the plain text. Here it is fairly simple how it is going to work. The input, that is the input text which is of length 128 bits is going, initially whatever may be the size of the data, it is going to be divided into 128 bits block, and that is going to be divided into 16 blocks of bytes, right. And then key is also expanded to match the same length, and it is permuted. Here it is shuffled before entering into the round. As soon as it enters as an input to the first round, we are here able to see yes, which is called as substitution blocks. It is going to substitute bit by bit for these input text, and then the output from this is fed as an input to the permutation and mix column. Okay. The output from the substitution block will be fed as a rows and column form to this permutation block where it is permuted, and then the rows are shifted and mixed with the column value here. Okay. And then that is fed as an operand to exclusive OR operation. Here we are performing exclusive OR operation for these text and the keys. We are getting the versions of keys from key expansion methods which is happening here, and it is exclusive OR, and the cipher text is passed as an input to the next round. So, the same procedure is repeated for number of times. Here in this case it is 10 rounds. So, at the nth round or at the last round we do not have this mix column procedure performed. Okay, only whatever input that is being fed as an input here, whatever text, so that is substituted and then that is permuted or shuffled and fed as an input to exclusive OR operation, the output of which is once again our totally 128 bits ciphertext. Okay, and then this 128 bit ciphertext is passed over the network, and on the other side at the receiver end the same procedure is followed in a reverse order as a decryption algorithm in order to get back whatever text that we had here at the initial stage. Okay, this is how advanced encryption standard works. So we have studied about data encryption standard, in which we had 16 rounds of operations, identical operation performed on the input data along with the key. There we were using 64-bit key and 64-bit plain text. Here in this case advanced encryption standard, we are going to perform operation on 128 bit length of plain text message with 128 bits of secret key. Okay, and the same procedure is carried out for all the rounds except the last round. In the last round we are not going to mix. Here at each round substitution block substitutes bit by bit on each plain text blocks, and then it is shuffled and mixed by shifting the rows and mixing it with the column values, and then the output or cipher from this particular phase is fed as an input to the exclusive OR operation, where we are performing exclusive OR operation of text which we have shuffled here along with the keys which we are getting by key expansion method throughout the process. And the same thing is repeated for last but one round. At the nth round mixing column is not there, remaining things remains the same, and finally we will get the ciphertext of 128 bits length. Okay, this is how these two protocols works. So this finishes our understanding or study about secret key encryption. Next we will try to understand how public key encryption method works. Okay, so far we have studied about secret key encryption, right? Now we will move on to discussion of the next topic, that is public key encryption protocols. So the topic of discussion is public key encryption. Okay, the introduction of public key encryption protocol has really created a major revolution, okay, in the field of cryptography. So this actually maintains a clever method of key exchange between sender and receiver. In our previous discussion we have seen that a single key is used on both sender and receiver side in order to encrypt as well as decrypt the given message. But here in this case all the systems which are taking part in encryption or decryption or the entire process are going to generate two separate keys. So two separate keys are used in order to encrypt and decrypt the message which is passing through the network. That is why we call this method as asymmetric or two key encryption. In the previous method it was symmetric and a single key encryption. Here it is asymmetric and two key encryption, because we are going to make use of two keys here, one at the sender side and one at the receiver end of the transmission. Okay, this is about the public key encryption. When I am telling that we have two keys, how can that be used? Okay, each system which is going to take part in the encryption method is going to generate two keys using several, there are plenty of algorithms or protocols available to generate that. We will see only two among them going further. Okay, so using some method each of these system is going to generate two keys. Okay, key 1 and key 2. We can use any one among these two for encryption. If I use K1 for encryption, K2 acts as a decryption key. If I am going to use K2 as an encryption key, K1 is used as a decryption key. One among them is made as public and that is going to be the encryption key, and the remaining key is kept as a private key for that particular system. So, if for example, if I want to send a message from A to B, okay, both A and B will generate two keys. Okay. A will generate two keys K1, K2, B will generate some B1, B2 as its key. Okay. A1 will make K1 as public, it will be entered into public register, and that is going to be the encryption key that is going to be used for encryption, and K2 is kept as private key, which is going to be used for decryption at A. Similarly, B also publishes one among these two as encryption. For example, B2 might be published as public and that is for encryption, and B1 is kept as private, which is used for decryption. When A wants to send a message to B, then A encrypts the text message using the public key of B, because A wants to send its message to B, right. So, this makes use of the public key which is generated in order to encrypt, okay, and encrypts the message. The ciphertext, the output after the encryption, that particular text is transmitted to B. Upon receiving the ciphertext, B is going to decrypt that message by making use of this private key, which is very confidential. This private key will not be made available for any other system apart from B. Okay, it is purely confidential. So, this is how with the usage of two keys we can perform encryption. Similarly, if some other system C wants to send information or message to A, then that is going to make use of key K1 in order to encrypt, right, and A makes use of key K2, which is a private key as far as A is concerned, and decrypts that message. Okay. This is how public key encryption works. Here the security level of encryption is totally dependent on the length of the key. As the length of key grows, the security level will also grows as more powerful. Okay. So, the security level is directly proportional to the length of key here. Okay. This is about the general introduction about public key encryption algorithm. And one more thing, in case of private key encryption or secret key encryption, what we had seen, we had observed that at every round so many permutation were happening and substitution were happening, right. But here in public key encryption, mathematical calculation plays a major role here. So, mathematical calculations plays a major role in order to calculate or find out the key here in case of public key encryption, whereas in our previous method, that is secret key encryption, we were using substitution and permutation as a method to generate a ciphertext, right. Now, we will see two protocols under this. One is RSA and one more is DH. Okay. These two are the protocols which works under public key encryption methodology. We will see to it one by one. Okay. Now, we will study about RSA algorithm. So, RSA algorithm means Revert, Shamir and Alderman, who actually derived or invented this particular algorithm. This algorithm again is used to find two keys, one for encryption and one more for decryption. This majorly works on 512 bits. Usually it works on 512 bits of blocks of text, plain text. Okay. This algorithm consists of three stages. or 3 steps. First a key is generated, and then making use of those keys encryption is done, and the third phase is decryption on the receiver end. Okay. How to generate a key? Okay. There are 6 steps involved in this. The very first step is choose randomly or roughly, it is going to choose 256 bits length prime numbers. Okay. It should be of length 256 bits, okay, and it should also be a prime number. So, what do we mean by prime number? A number which is divisible by 1 and itself. Okay. So, randomly or roughly 2 prime numbers are going to be selected, which is of length 256 bit length. Okay. And then we call those two as A and B, and we derive n, which is product of A and B. Okay, product of those two numbers. Next we are going to find x. X is our encryption key, the key which is going to be used for encryption and which is a public key, which is made as public. We find x such that x and the product of A minus 1 and into B minus 1 are relatively prime. So, what do we mean by that? What do we mean by relatively prime? We say two numbers are relatively prime if they have only one, number 1 as a common factor. Okay. Other than 1, we should not have any factor for those two, okay, any common factor for those two. Okay. So, the product of these two, A minus 1 into B minus 1 and x, should be relatively prime. In such a way, we are going to find x. Okay. After finding x, we are going to calculate y, which is used as a secret key here for decryption. So, using this equation, y is equal to x y mod A minus 1 into B minus 1 equals 1. Using this particular equation, y is calculated. Okay. Here in this, we know the value x, we have just calculated, and we know what is A, what is B. So, using these values, we are going to determine what is y. Okay. Now, we have x and y. Okay. Since we have both the keys, we will discard the values A and B, which we selected at the first step. So, that becomes our fourth step. So, we are discarding A and B here. After that, public key will become the combination of x and n. Combination of x and n is declared as public, which is going to be used for encryption. Combination of y, which we calculated using this formula, along with n, acts as a private key, and it is kept as confidential in order to decrypt the message whatever that particular system gets. Okay. This is about the key generation part. Once the key is generated, okay, if I want to send some information to other system, we will look into the key which is generated by that system, and we will take the public key for encryption. So, in order to encrypt that, this particular formula is used. C is a ciphertext, which is output that we get after encrypting the given message, which is M. M is our message, C is ciphertext, and we know the value of n and x, which is a public key. Okay. So, with that value, we are going to calculate the ciphertext using this formula. C is equal to m to the power x mod n. The message is transmitted. On the receiver end, the receiver will have its secret key, right. Here encryption is done with a public key that is calculated by the receiver, right, and then the message is encrypted and it is transmitted over the network, and in order to decrypt that, the receiver makes use of its key, secret key, which is y, okay, the private key. So, we have y and n available, we have ciphertext. With these things, we are going to calculate or get back our initial text using this formula. M is equal to C power y mod n. So, this is how encryption and decryption can be carried out in case of public encryption method with respect to RSA algorithm. Is that clear? Very simple and straightforward, isn't it? Now, after understanding this, we will move on to the next protocol which falls under the same category, that is public key encryption method. Okay. Now, we are going to study about one more protocol which comes under public key encryption, and that is Diffie-Hellman key exchange algorithm or protocol. Okay. Here the two users, user A and user B for example, okay, the two users who want to exchange information between them comes to an agreement to work on some shared secret code. Okay. This will not be made available earlier, just before the transmission of the message, this will be made available for them mutually. So, intruder will not be able to interrupt and get to know about that particular secret code. Okay. This particular methodology or protocol is mostly used in VPN, that is virtual private networks. Okay. This is very simple and straightforward. When user 1 and user 2 wants to have a transmission of data between them, how it will be done? User 1 randomly selects three numbers, okay, one prime number and that can be called as A, and one random integer that is x1, and one generator that is G. These three things or these three numbers are randomly selected by user 1. Okay. Making use of these three as an input, it is going to generate a key y1. Okay. It is going to generate a key and we call that as y1 using this formula G per x1 mod A, where G is a generator, x1 is a random integer and A is a prime. Okay. Similarly, user 2 also makes the same thing, or it follows the same procedure. It chooses the three numbers, one prime and one a random integer and one generator. Okay. So, with the help of that, user 2 also calculates its key. Okay. We call that as y2 and using this formula G per x2 mod A. Okay. So, now both user 1 and user 2 is going to exchange these keys. This is user 1 key, this is user 2 key. User 1 sends this key to user 2 and user 2 sends this key to user 1. Okay. With the help of this key, so these two are used for encryption. Okay. With the help of these keys, user 1 and user 2 calculates its secret key. Okay. How it is going to be calculated? Since user 1 receives a key y2, receives a key from user 2, that is y2, with the help of this it is going to calculate its key for decryption. Okay. So, y2 per x1 mod A will give the first key, and similarly the same procedure is followed by user 2. So, making use of this key which is generated by user 1, it is going to generate its key k2 using this formula y1 per x2 mod A. So, keys are available, the message is encrypted and transmitted, and the receiver end it is going to be decrypted. So, this is how public key encryption works, very simple and straightforward. So, this finishes our topic of encryption method or cryptographic methods of providing security to our computer networks. In the next class, we are going to study about authentication. Under that, we are going to study about message digest and digital signature, how it is going to provide security over the message. Okay. So, we are going to study that in our next session. Thank you.